All right, so the subtopic being intersection and union of sets. We can say if A and B are two sets, then the intersection of A and B is the set of all elements that are common to both A and B. So let's say we have, all right, let's explain this a bit further. Let's say we have this set here and we have this set here. And we have 1, 2, 3 over here, and over here we have 2, 4, 6. Now, it says that the intersection of two sets, or let's name this set B, and let's say this is set A. Now, they say that the intersection of A and B, it's going to be all the elements that are common in both of the sets. Now, if you look carefully here, the only element that B and A has in common is going to be the number 2. So if we are to say the intersection of A and B, the intersection of A and B will be 2, because 2 is common here. All right. We'll get this off. That is, A intersect B is equal. Remember, we did set builder notation, so this should be, it should not be confusing. We are already accustomed to this. A intersect B is equal, X is such that X is an element of A and X is an element of B. Like the example we did, we have 2 being an element of A and 2 being an element of set B. Now, let me just get this off. Now we'll take a look at a Venn diagram that's going to show a bit of the explanation for this here. So looking carefully at this Venn diagram, we have the parts that are highlighted. Now, when there is an intersection of two sets, when something is common in that two set, we will have the Venn diagram being like this, where the circles, they intersect each other, and this red area here is where the intersection would be. So if we were to take the example that we had before, this in this red area here, the 2 would have been in this red area here, because the 2 was the intersection of the two sets, and this here is the intersection part. So we say that the intersection is here, and the B only, it's going to be here, A only, it's going to be here. Note that this, excuse me, this rectangular box here and this U here stands for the universal set. That is everything that is in this set. Note that there is something else that you must know, that this here, A intersect B complement, this here, A intersect B complement means A only. That means the elements that are only in A, and B intersect A complement here is going to be B only, only the elements that are in B. So only the elements that are in A and B alone is going to be, well, the arrow indicates here, and A complement intersect B complement, A complement intersects B complement. That means that it doesn't belong in either of the sets. So it's going to be outside in the rectangular box here. It's going to be outside. It's not going to be outside here or outside here. It's still in the universal set, but it's not in A, neither is it in B. Now that as we move on further into the lesson, we will get more familiar with the stuff. So let's look at an example. Let U, excuse me, let U equal 11, 12, 13, 14, 15, 16, 17, and 18. So U, we can establish that U, this here, is the universal set. All right, it's the whole entire set. Now, if A is 12, 15, and 18, and set B is 13, 17, and 15, then A intersect B is written as A intersect B, and that is equal to 15. Remember, when we're looking at intersection, we say what is common in A and B. So we are looking at set A and we are looking at set B. Now, the only thing that is common in set A would be this 15, and 15 is also in set B. So we can clearly say that A intersect B is equal to 15. And we write that as A intersect B is equal to, you put your curly brackets because we denote the set by using curly brackets, is equal to 15. And that's how we write it. Now, A intersect B complement, that is this here, A intersect B complement is written as this here. A intersect B complement is written as this here. This little, what you call it here, that represents complement. So A intersect B complement means A only, and that is equal to 12 and 18. Now, A only stands for the elements that are only in A. So after we have highlighted the intersection, therefore, A only is going to be the 12 and the 18. A intersect B complement, it means A only. So only 12 and 18 after we had identified the intersection. That's the only stuff we'll have. So A intersect B, this little thing at the top here means complement, is equal, you use your curly brackets, and it's going to be 12 and 18. That is A intersect B complement. Good. Now B intersect A complement, B intersect A complement is written as this here, B intersect A complement, and that means B only. So that is only the elements that are in B. So when we look at this head here, when we had already identified the intersection and so on, only 13 and 17 is going to remain, or 13 and 17 is going to be B only. So we can write now A intersect B complement, A complement intersect B complement is equal to, and we write our 13 and we write our 17, and that is it for that. So we look at the Venn diagram, because in the exercises that you will have to do, you will have to construct Venn diagrams, and you may have to read Venn diagrams or look at the Venn diagrams and identify certain parts of the Venn diagram. Now, we have the Venn diagram that was used to represent the information. So we already identified 12 and 18, that is going to be A only. We have B only here, it's going to be in B here. And we have the intersection. Now, if you were to recall that some of the numbers were not in the set, so the numbers that were not in A, neither were they in B, we place them out here. We're not place them out here, you know. It's being placed in the rectangular box. It's still in the universal set, but it is not in A, neither is it in B. So that's why they come out here. All right, so we're going to move on to another example. Well, this here covers intersection. Everything about intersection, this here covers intersection. Now, if you look at here, we're looking at intersection and union of a set. So what we did here, we did the intersection of sets. Now we're moving on to union of the set. Good. So the union of two sets, A and B, is the set of all elements that are in either A or B. That is, this comes back here again, same set builder notation styling, we encountered again. A intersect B. Let me just get this here. Just get this properly. So we have A intersect B. This here, same set builder comes back. A intersect B is X is such that X is an element of A or X is an element of B or both. Now we say that a union is basically everything that is in A and everything that is in B. So taking the same example that we did before, where we have 2, 4, and 6 here, and we had set B being 1, 2, and 3. Now, the union of this set is everything that is in set A and everything that is in set B. Now, sometimes you may encounter the intersection, that since we know that the intersection is going to be the number that is in both sets, and it's going to occur 2 times if you look at the sets, them separate, but you don't have to write it back. So basically, we can write the union of this set here, this example that we have here is going to be 1, 2, 3, we have 4, and we have 6. So that is basically the union of the set. It is all the elements that are in A and it is in B. And as you can see, it is written as A union B. So if we were to write this here, we would have had A union B is equal, and we continue, right? We list the elements that are in both of the sets. Okay, so let's get this off and let's move on. Good. The Venn diagram, same thing, the Venn diagram, we're back with the Venn diagram. You use to represent the following statements. So it identifies the parts. So as you can see, A union B is everything here. A union B is all the elements within the set that is this orange spot here. Now A union B complement, when it's in this bracket, A union B complement, that means that everything that is outside of A and is outside of B, it is neither in both of the sets. So if it's in neither of the sets, it's written out here in the rectangle, right? So that is A union B complement. Once it has this bracket here, the bracket, and in the bracket it has A union B, and it has the complement sign outside. That is everything that is not inside of the set. Once it's not inside of the set, it's going to be in the rectangle area of the box. Right, so that's it for that part. Now we have an example. All right, let's look at the example. So let U equal, same thing comes back here, same example that we did before, 11 to 18, A equal 12, 5, 18, B is 13, 15, 17, and A union B, we establish how that is written. A union B is written as A with a U, the symbol that looks like a U, and then B. And we say that is everything in set A only and B only. So A union B is equal to everything here. And as you can see, it's written here. And the complement of A and the complement of A union B, I explained that before. This is this here. A union B complement, we say that that is everything that is outside of A only and outside of B only. So everything that is outside of the set, when they give you the universal set and you see that we had the other numbers and we had 11 that was not used. We have 14 and we have 16. These numbers were not in any of the sets. It was not an A or B, so that is going to go, if you're to draw this in the Venn diagram, that is going to go in the rectangular box. It's not going to be in the set A, it's not going to be in the set B, it's going to be in the rectangular box. And same thing comes back here, A union B complement. Now, moving on. Just get this. Good. Now A complement intersects B complement. Now note how that is written. A complement intersects B complement is written as A complement intersects B complement. Now that again, A complement intersects B complement is the same thing as A union B in the bracket complement. It's the same thing as this here. So we can safely say that A union B or complement is equal to A complement intersects B complement. It is the same thing. And it's going to be whatever numbers, it's the same 11, 14, 16. And like we established that is going to be in the rectangular box and it's neither in set A nor set B. Remember that it's everything that is outside set A and everything that is outside set B. So let's take a look at the Venn diagram that is going to be used to represent this information. So like we said, the same thing to the previous example, just that they highlighted the union of A and B. A union B complement is everything that is here, right? Everything that is here, right? That is the whole of A union B. So that is basically it. It's nothing tough, just that you have to be careful when you're doing your Venn diagram and so on, drawing up and constructing and so on. So you have some exercises here. We have 1, 2, 3, 4 exercises. So let's go through this quickly. Given that given that X is equal to 1, 2, 3, 4, 5, 6, 7, 8, and Y is equal to 2, 4, 6, 8, 10, 12, 14, 16, 18, then the elements in X union Y, X unions Y, so X union, okay, let me just write this back. Write this X properly. So let's have X union Y. We know that that is everything in the sets, right? So we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't have 11, but we are given 12. So we have 12, we don't have 4, we don't have 13, so 12, 14, 16, and we have 18. So that is X union Y. Everything that is in X and everything that is in Y, and please don't, not because we have 1 here and not 1. Let's say we have 2 here and we have 2 here. That means you're writing it back 2 times. You're not. Just write. Just list. Go ahead and list the elements as they are. So that is this here, X union Y. Now, X intersect y now is completely different. Now we established that intersection is something that is in common, in both of the sets. So let me just change the color. Let's take a look. Let's use the, come on, blue color. Good. So what is common in the two sets? We have 2 here. We have 2 here. We have 4. We have 4. We have 6. We have 6. We have 8, and we have 8. We don't have anything else. 2, 4, 6, 8. All right. Good. So, okay, so A, not A, why do I keep saying A? X intersect Y, it's going to be 2. It's going to be 4, 6, and 8. So that is basically it there. Now, another task that we have is to draw a Venn diagram to show the union of the two sets. Now, let me get a different color. All right, let's draw the Venn diagram here. It's going to cover some of the other exercises, but that's okay. So we're going to have our Venn diagram. We put our union sign. We have our union sign. And let's draw our two sets. And of course, we have intersections. So we know that the two circles, they're going to loop over each other, right? So we have this coming here. And we will have this coming here. And we know the intersection. We know what is going to come in the intersection, right? We will have 2, 4, 6, and we will have 8 coming here. And the other numbers, this is going to be X. Let's represent this by X, and this is going to be Y. Now the elements in X, we can use the elements in X to be, all right, so we have 1, we have 1, we have 3, we have 5, 7, and 9. 1, 3, 5, 7, and 9. Y, we have what word wasn't used. We have 10, we have 12, we have 14, we have 16, and we have 18. So that's about it. We don't have any number that was not used. If we did had some other number that was not used, then it would have come, outside here, but we don't have any number that was not used. So this is what your Venn diagram should look like. Be careful, just look for the different colors so you know when you're making your corrections what you are looking for. So this is it for exercise number 1. So we're moving on to exercise number 2 now. Just let me erase, clean this out quickly. Okay. So get this clean. Get this off. Okay, so let's move down to exercise number 2. Good. Given that A is equal to 3, 6, 9, 12, 15, 18, 21, and B 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, then the elements in A intersect B. All right, so we're only looking for intersection in this case. So we just look for what is common in both of the sets. We have 3 here, we have 3 here. What else do we have? 15, no. 11, no. 17, no. 19, no. And we have 21. So A intersect B, this is equal to, we have 3 and we have 21. So this is basically your A intersect B, 3 and 21. Now we have to draw a suitable Venn diagram to represent the intersection of the two sets. So, okay, I'm going to draw the Venn diagram at the bottom here. So number 2 Venn diagram is being drawn here, right? So let's drop the Venn diagram. And we have, oh, don't forget your union here. Okay, let me just get this properly. Take this part off. Oh boy. Okay, we have we have our circles where we have intersections, so we know what's happening. We have our circles overlapping each other. Okay, and we have A, it's going to be here. We have B is going to be here. And suitable to represent the intersection. So we have our, let me just put the intersection in a different color. Let's put our intersection in, come on. So we will have 3 and we have 21. And this here is the intersection area. So if you would like, you can probably just highlight it. Just highlight it. So we know that this here is the intersection area, and the other, if you want, you can list your other elements in here and here, okay? So that's about it. So this is your answer. 321 is intersection, and draw a suitable Venn diagram to represent the intersection of the two sets. So this, the green here will be the intersection, right? So that's it for number 2. Let's move on to number 3. Just clean this out quickly. Okay, clean. Okay, got this off. Okay, so number 3 says, describe the shaded areas in each of the following Venn diagrams. You are looking at A, B, and C. Okay, let's see. All right, so it's A, B, C. Now describing it, we just write what basically it is representing or displaying. So that is basically what we're just representing. So, excuse me. All right, so looking at A, we know that everything, we encountered something like this before. A and B, everything is shaded for A and B, even the intersection area is shaded. So we can simply say that this here is actually A union B. Okay, this isn't neat. This is not neat. Let me just get this back. All right, we can say that this is A union B. That is A union B. We have B, everything that is outside, everything outside is shaded. So the easiest one we can remember is we can either use, for this one, I'll write this one here. We can either use A complement intersect B complement, or we can use A U, oh, no. All right, so A union B bracket or complement. Either one is correct for this one here. Okay, this one. Come on, arrow. Yes, this one. That's the answer for this one. And C, it's just, if you look here, it's just B, A, and it's just the intersection part that is highlighted. So we can safely say that this is B and A intersect B. That is this answer, A intersect B. So this here, A is being A union B, B is being A complement intersect B complement, or A union B or complement. Either one is correct for B, and this here it's A intersect B, and that's about it for this here. So we're moving on to the final exercise. So just let me clean this out, get this off so we can. All right, so last one. Here isn't clean properly. Last one. So we have if P is equal to 3, 6, 9, 12, and 15, and Q is equal to 2, 4, 6, 8, and 10, state the elements in P intersect Q, draw a suitable Venn diagram to represent the information, and shade the region P intersect Q. So this is a lot here. So let's work with P intersect Q. I'm going to write it up here. P intersect Q. Well, we know that that is whatever is common in P and whatever is common in Q. So we can look, we have 3, no 3 over here. We have 6 here. Yes, we have 6 here. 8 and 10 remaining. We don't have 8 and 10 here. So P intersect Q is just going to be 6. Now draw a suitable Venn diagram to represent the information. So we'll draw our Venn diagram here. Now we know that U is going to stand for our universal set, and we're going to draw our circles. Oh boy. Oh no. Just let me get the circle back properly. We're going to draw our circles. Good. So P intersect Q. We know that P intersect Q is 6. So we'll put 6 here. Draw a suitable Venn diagram. Shade the region P intersect Q. And let's shade this region one time. We'll shade it in red. P intersect Q is this section here. P intersect Q. And then, okay, let's label our sets. This is P and this is going to be set Q. What else? We have to put in the numbers that's in P only. So we have numbers that's in P only. So P only is going to be 3. We're going to have 9, 12, and we'll have 15. 3, 9, 12, 15, and we're going to have 2, 4, 8, and 10 over here. 2, 4, 8, and 10. Represent shaded region P intersect Q. Okay, so it's shaded. So this is what our Venn diagram looks like. So this is going to be P intersect Q, and this is our Venn diagram. Now that's it. So please make your corrections where necessary, and that's it.